Okay, good morning Year 12 single mathematicians. Just going to continue with mechanics chapter 10, 10.6 on pulleys. Go straight into it because there's nothing new to add. We're still using Newton's laws. We're still pretty much using exactly the same strategy as previously, but it's just a different style of question. It's got a pulley in it instead. So EG number 1, we've got two particles P and Q of masses 2m and 3m, so not numbers exactly, are attached to the ends of a light inextensible string. The string passes over a smooth fixed pulley and the masses hang with the string taut. So this diagram would be there's your pulley. The string's going to hang over the pulley, like so. And then you've got two objects. That one's P. Second object, Q. This has a mass of 2m. This has a mass of 3m. And that's pretty much all we're told. Now, yeah, those masses mean kilograms, so 2m kilograms and 3m kilograms at the start. Not meters, not 2 meters or 3 meters, it's 2m kilograms. System is released from rest and we have to find the acceleration of each mass. So if you think about this, if you set this experiment up, this system is going to move once you let go. And it's obviously going to fall in the direction of the 3m. 3m is heavier than 2m, so it's going to fall in this direction. So Q is going to accelerate down. And at the same time, P is going to accelerate up. And these accelerations are the same, just pointing in opposite directions. Right. Let's consider one particle at a time. So force is acting on, let's do resolve object A. Sorry, object P, what am I talking about? Resolve object P. What forces are acting on object P? Well, it has a mass, so it will have a weight, 2m times g newtons. And it's attached to a string, so there's a tension, T newtons, and that's it. There's no reaction force, there's no friction because it's a smooth pulley, just a weight and a tension. Now, in that direction, this vertical direction, this object is accelerating, it's going upwards, so there is a need for Newton's second law. This object has mass 2m, and its acceleration is a, unknown, 2ma. And that's one way to work out the resultant force. The second way is the force is going with the motion, subtract the forces going against it. So T subtract 2mg. And I can leave it like this. This is one equation, can't really do too much with it at all. Right, resolve the other particle. It's exactly the same strategy for every single one of these. Resolve one of them and then resolve the other one. Two equations and probably two unknowns. Right, Q has a weight, 3 mg newtons. Again, it has a tension, T newtons, and it is accelerating, this time downwards. So F equals ma. The mass of Q is 3m, and the acceleration of Q is a. Now this is where you could make a mistake. So resultant force, this time Q is going downwards. So going with the motion, 3mg, subtract resisting the motion, T. Equation 1, equation 2. How can you solve these simultaneously? There's lots of unknowns. Well, I think we did this before, but your plus t there and a minus t there, if you add them, see what happens. T's disappear. 3mg plus minus 2mg is 1mg, and 2ma plus 3ma is 5ma. And it looks like you've got an equation with lots of unknowns still, but you can divide by m. And then if you make a the subject, you do g, which is 9.8, divided by 5, which is 1.96 meters per second squared. And that's the acceleration of both. Part B, find the tension. Well, simultaneous equations it was, let's find t. So substitute it into equation 1, part B. T is equal to 2mg plus 2m times 1.96. And okay, we're not going to get an actual numerical answer because we've got m's in there. But if you factor the m out, you get 2g plus 2 times 1.96, which gives you 2 times 9.8 plus 2 times 1.96, 23.52 m newtons. Okay, and part C, find the force exerted on the pulley by the string. So for this one, I'm going to consider the force is pretty much acting on the string by the pulley. So the string, well, there'll be a tension pulling it down there, and there'll be a tension pulling it down there. But then it's in contact with the pulley, so there's going to be a reaction force there. And because this pulley is stationary, i.e. not accelerating, we can say part C, all of the forces balance out with each other. So R equals T plus T, or R is equal to 2T, so double our previous answer. So 2 times 23.52 gives you 47.04 m newtons, would be that. Okay, let's do part D. So part D is asking to find the distance moved by Q in 4 seconds, assuming P does not reach the pulley. So Q is going to fall, P is going to go upwards. In 4 seconds, this string is long enough so it doesn't hit the pulley, otherwise something different would happen. So we're just going to let Q drop for 4 seconds. I want to find the distance moved. And it is suvat. So it's suvat for part D. So part D, S is displacement or distance in this case. We want to work it out. U is equal to initial velocity. Now if you remember right at the start of the question, the system is released from rest. So U is 0. Final velocity, don't care. Acceleration. Okay, full acceleration now is the one we worked it out to be, 1.96. It's definitely not 9.8 meters per second squared, because that is when it's in free fall. So in other words, the only force acting on it is its weight. No longer happening for this one. We've got tensions and everything. So 1.96 and t is 4 seconds. And we've got a formula linking S, U, A and T, which would be S equals UT plus a half AT squared. Substitute everything you know, 0, 4s plus a half, 1.96, 4 squared. Type that into your calculator. Start disappears, so it's just 0.5 times 1.96 times 4 squared, which gives you 15.68 meters. Okay, part E, one marker left. State how you've used the fact the pulley is smooth. So this modelling assumption is ignore friction. And if you think about it, that means on the pulley there where the string is attached, no friction is considered, so these tensions would be the same. So in other words, assumes tension is constant throughout. That would be part E. Yeah, that's a really long question. I'm going to ask you to try some similar ones from the textbook. So if you find, let's have a look at this. Page 175, exercise 10F. I'm going to try question 1, question 2, and question 3. So the first 3 questions, and if you've got any problems with any of those questions, then post a message on the Teams chat and I will get back to you.